Ever just look around at our world and wonder, how? How does a skyscraper stand perfectly straight? How does a massive bridge meet exactly in the middle? Or even, how do we know for sure where your backyard ends and your neighbor's begins? Well, it all comes down to knowing, with absolute certainty, where things are. Today, we're going to dive into the incredible story of surveying. I mean, just look at this thing. It's like a beautiful, chaotic dance of concrete and steel. You've got tons and tons of material all weaving together with what has to be pinpoint accuracy. It honestly looks kind of impossible, right? So how on earth do you pull something like that off? Well, the answer is this amazing mix of ancient arts and modern science. It's the crucial first step that has to happen long before a single shovel hits the dirt. It's called surveying. Surveying is, at its heart, the act of creating the master plan for our physical world. Before anyone can build anything, surveyors are out there, measuring and mapping, creating the blueprint that guides the entire project. In fact, you could say the success of the whole shebang really hinges on their precision. But to really appreciate where we are today, we have to go back, way back. Long before satellites and lasers, surveying was a tough, physical job that relied on some surprisingly clever tools. So let's start with the absolute foundation of early surveying, the chain. And just look at this thing. This was no ordinary chain, not at all. This was a purpose-built, high-tech measuring device for its time. We can see the heavy brass handles for pulling it tight, the metal links that are all a precise length, and those little rings in between. They're there to keep it from kinking up. Even those metal tags had a job. They're called tallies, and they let the surveyors quickly mark out specific distances. Using it was a real team effort. You had a leader who would drag the chain forward and a follower, back at the start, literally shouting directions to keep the line perfectly straight. Once it was taut, the leader would jam a metal arrow into the ground. Then they'd do it all over again, with the follower picking up the last arrow as they went. It was slow, it was methodical, and it was completely manual. And what's really cool is they had different chains for different jobs. The engineer's chain, for instance, was a nice round 100 feet long. Simple. But the Gunter's chain, that was pure genius. It was exactly 66 feet long. Why? Because it turns out that 10 square Gunter's chains is exactly 1 acre. They literally built the math for calculating area right into the tool itself. How smart is that? But, measuring in straight lines will only get you so far. To map anything complex, like a valley or a hillside, you have to be able to measure angles. This was the next huge leap forward for surveying, taking it from simple lines into the world of trigonometry. And this is the machine that made it happen, the theodolite. You can think of it like a super precise protractor mixed with a telescope. A surveyor could aim the scope, rotate it horizontally and vertically, and read these incredibly fine-tuned dials to measure angles with amazing accuracy. This let them map out huge areas just by creating a network of triangles. But even with an instrument this precise, surveyors faced some really sneaky problems. One of the biggest was something called local attraction. Basically, their compasses could get totally thrown off by any metal nearby. Railroad tracks, a wire fence, even the keys in their own pocket could pull the needle away from true magnetic north. They had to come up with all these complex mathematical checks to catch and correct for these invisible magnetic fields. For hundreds of years, surveying was tied to the ground. It was all about what you could physically see and touch. And then, in the late 20th century, everything changed. We started looking up to satellites. And the digital revolution completely rewrote the rules of the game. I mean, the difference is just staggering. Manual surveying was slow, you had to have a clear line of sight, and you were limited by the terrain. Digital surveying, on the other hand, uses satellite signals. It's almost instant. It works anywhere on the planet. And, get this, it can be accurate down to the centimeter. It's not just a step forward. It's a quantum leap. At the heart of all this is the Global Positioning System. Yep, good old GPS. It's this whole constellation of at least 24 satellites zipping around the Earth about 11,000 miles up. You can think of each one as a super accurate clock in the sky, just constantly beaming a time-stamped signal down to the rest of us. So how does this actually work? Well, it's this brilliant process called trilateration. First, your GPS receiver on the ground catches a signal from one satellite. It knows how long that signal took to get there, so it can figure out exactly how far away that satellite is. What that means is your location is now narrowed down to somewhere on the surface of a giant invisible sphere with the satellite at its center.
Okay, but being somewhere on a giant sphere isn't very helpful. So the receiver listens for a second satellite. This creates a second invisible sphere. Now, where can two spheres possibly meet? In a perfect circle. So just like that, we've gone from a whole sphere of possibilities down to just a circle. We're getting a lot closer.
Now for the third satellite. A signal from a third one creates a third sphere, and that sphere can only cross our circle at two possible points. We are so close, and that's where the fourth satellite becomes absolutely crucial. Its signal not only confirms which of those 2 points is the right one, but it also acts like a time check, syncing everything up and locking in your exact three-dimensional spot on planet Earth. Having all this super precise location data is one thing, but its real power is unlocked when we start to organize it. That's where Geographic Information Systems, or GIS, come into play. The easiest way to think about GIS is to imagine you have a stack of clear, transparent maps. One layer shows all the roads. Another one on top shows all the buildings. A third one shows all the trees and parks. When you stack them all up, you can see how everything relates and find patterns you'd never see otherwise.
So we've gone on this journey from dragging physical chains across the ground to catching invisible signals beamed down from space. It's been an incredible evolution, and it's taking us from just measuring the world to actively modeling and shaping it in real time. And really, this picture just says it all. On the left, you've got the muscle and the metal of the past, and on the right, that's a modern bulldozer being guided by high-precision GPS, grading the land perfectly to match a digital design, all by itself. The surveyor's data is now talking directly to the machines. It's amazing.
Which kind of brings us to the core idea here. The technology, from the Gunter's chain to the GPS satellite, has changed in ways that are almost unrecognizable. But that fundamental human need to understand our space, to map it out, and to build our world upon it, that hasn't changed one bit.
And that leaves us with a pretty fascinating thought. We've hit a level of precision that our ancestors couldn't even dream of. We can model our world in real time. So the question isn't really, can we measure our world anymore? The question now is, with this incredible power, what are we going to build next?